Welcome back. We're on Chapter 1, Lesson 5, Graphing Ratio Tables. Please turn to page 47. Now let's look at the vocabulary. We've already learned about this in Chapter 5, so this should be very familiar. We call the graph a coordinate plane. Notice that we're only dealing with quadrant 1 because we're dealing with the positive numbers. The y-axis is vertical. Why? Because you can make a tail out of the y. The x-axis is horizontal. Our ordered pair are represented with parentheses. And again, this is open parentheses x, comma, y in alphabetical order. And then where 0 and 0 meet, we are at the origin, or 0, comma, 0. Let's look at the real world link. It's very important to make labels when we're talking about axes. In this case, we have 3 minutes. A North American wood turtle can travel about 17 yards. If the x-axis is minutes, notice we wrote minutes because x is the first one. And then the y represents yards. We can now fill in our table or fill in our ordered pair. 3, comma, 17. Turn the page. So just to recap, our x-coordinate is the first letter in the alphabet when we're talking about x, y, z, and then y is the second. In the case of our example previously, it's 3, comma, 6. Now let's look at the example below. All right, in the first example, when we're talking about tables, we have a table that shows the cost of dollars to create CDs and digital photos at a photo shop. The table also shows this information in ordered pairs. So the X is the number of CDs and the cost in dollars is Y. So again, always make sure that you understand which is which. In this case, this is the CDs and this is the cost. That might help you if you write it like that. Oh, look, we have a circle from the last time. We'll just erase it. All right, so we need to graph the ordered pairs. In this case, we go over. Remember, always go over and then go up. This is X, this is Y. So we're going to graph 1, 3. Over 1, up 3. Put a dot. Over 2, up 6, put a dot. Over 3, up 9, put another dot. Now, when we describe the pattern of the graph, what do you see if I start at the origin or 0, 0? Let's see. If I put my pencil on here, I'll go straight through these numbers. This is called linear. So I have a line, get it? And that's called a linear graph because it contains the word line. So for every $3, I get to make a CD. Get it, got it, go. Pause the video. Did you get what I got? When I graphed it, I got a straight line. Again, over 1, up 5. Over 2, up 10. Over 3, up 15. So I have a linear graph. And the relationship is for every $5 I earn per hour. So saying this all wrong. I earn $5 an hour. Back here, the X is hours and the Y is money. So again, for every hour I earn $5. And we would write that $5 an hour. Turn the page. All right, when we're comparing ratios, we can do two lines on one graph. Now, the greater the ratio, the steeper the line. So in this case, this is greater. And we call this the slope. Now, that is purely algebra, and you don't need to know what a slope is, but I thought I would throw that word in. Now, let's look at the table below in the example. Two friends are making scrapbooks. Renee places 4 photos on each page of her scrapbook. Gina places 6 photos on each page of her scrapbook. We need to make a table for 1, 2, 3, and 4 pages. Notice that our ordered pair is pages is our X value, and photos is our Y value. So let's look at Renee. Renee for one page has 4. 2 is 8, 3 is 12, 4 is 16. Here are our ordered pairs for that. For Gina, she can put 6 photos on each page. So for one page, it's 6 photos. 2 pages is 12 photos. 3 pages is 18 photos. And 4 pages is 24 photos. Now let's graph it. Alright, so now we're going to graph the ordered pairs for each friend in the same coordinate plane. Remember that pages is our X and photos is our Y. So look at the colored dots. In this case, Renee is blue. So for one page, over 1, up 4. 2 is 8, 3 is 12, and 4 is 18. So if I connect the dots, I draw a line, and Renee's looks like that. Then for Gina, one page is 6, over 1, up 6. 2 pages 12, over 2, up 12. 3, over 3, up 18. 4, over 4, up 24. And again, I will connect the dots. And Gina's is steeper than Renee's. And remember, when you're graphing, you don't have to have each number represented on the y-axis. In this case, it was every 3. So that means that you have to be careful when you're placing your dots. They don't have to be every 1. In this case, we're trying to get up to 24, and that would be a huge graph. All right, let's move on. Okay, 5. How does the ratio of photos for each page compare for each person? And how is this shown on the graph? So in this case, we know that Gina is the red one, and Gina can do 6 photos in one page. Photo, page. Renee's does 4 photos in one page, and Gina's is steeper than Renee's. All right, let's move on. Turn the page. This is a short lesson, and hopefully it was easy to understand. We're going to pause the video, do the guided practice, and come back soon. See you. Did you get what I got for problem number 1 and 2? We know that Marcus saves $10 a week and David saves $15 a week. So first week, Marcus is 10, second week, 20, third week, 30, fourth week, 40. David, on the other hand, saves $15 a week. So week 1, 15, 2, 30, 3, 45, 4, 60. Notice that David is saving at a steeper rate than Marcus on his graph. I'm now going to slide it down so I can get to the next question. So hold on. All right, question number 3. How are the ratios compared? David is $15 a week. Marcus is $10 a week. They're both linear, and David saves more. Number 4. How can graphing help? Because it's easy to see. Tables are not as easy to understand, but the minute you graph it, you have a picture, and it's easier to see. Hope you enjoyed my lesson. See you next time. Bye.